which are either difficult to teach or difficult for the students to learn. Now, we have come up with a set of sessions where Dr. Ramesh Chandra Srivastava sir will take you through each of the topic related to each of the subjects, and we'll be exploring certain ways, certain concepts, how it can connect with real world understanding. Now, these master classes are designed to help us deep dive into those challenging areas, guided by Dr. Srivastava's expertise. Over the next few weeks, we'll explore ways to strengthen our conceptual understanding, connect mathematical ideas into real world applications, prepare ourselves for the coming activities which we have designed under the Teacher in the Loop AI initiative with the support of AI. Now, before getting into the sessions by Dr. Srivastava, I would like to give you some understanding about the upcoming activities also that we have planned within the cohort itself. As you have already been informed that we have divided each one of you into specific groups. We also have a dedicated 20 mentors who are already a part of our previous cohort and who are also familiar with certain concepts and certain activities that we have previously done. Now, even for this cohort, we have a number of over 200 teachers with each connected with each mentor, and each group has at least 11 to 12 teachers from different parts of India who have joined together. Now, certain activities, and also why there is a group, why we have designed groups, and why we have divided teachers into different groups. Now, coming to that, certain activities that we have planned mostly will be done in the beginning. Mostly it will be done group wise, where you will be guided by your mentor, or certain activities will be as a group you will be doing it online, and we'll be putting you into specific breakout rooms where you will be doing certain activities within the group itself. Now, coming and the mentors, as I already mentioned, mentors have experience working with the process. They have experience working with the tool. They have experience working and designing certain activities, and they're also familiar with uh, the resources that we develop with the support of AI. Now, as you're all aware, we also recently launched a challenge with the concept, the difficult topic areas which you have identified during our bootcamp. What we are doing right now is we are crowdsourcing best resources from all over India. We all know that each teacher might be having a unique resource, a unique way of teaching a specific topic. So we are crowdsourcing from all the expert teachers across India. Now, this competition is open to everyone, so anyone can share their own resources. Once we receive a specific set of resources, then these resources will be shared among the groups, among each group. Let's say we have 20 groups, so those resources which are coming as an input from the competition will be shared among the groups, and there will be certain criteria, there will be certain rubrics. Your mentor will be guiding the process. Now, you as an expert teacher in this project will be the one who will be deciding which of these resources are eligible, which of these resources are good to train the AI. Now we are coming to the real part. Now, what we did in our first bootcamp is identifying the problem. So we identify the problem where we want to work, where we want solutions, where we want our student to perform better. Now we found the problem, we identified the problem. Now what we want is slowly we are building the solution. Now here we are also using the support of AI. AI is not there to replace you. AI is there to support you. Now, the thing about this AI or the project is that we together are the one who is going to design this tool. The AI is not training the teachers. Teachers are training the AI. Now, that is the concept that we are bringing in. I know some of you might be here thinking that you are going to learn so many things about AI, like introduction to AI, some tools that you can use in AI. You all are here for a purpose which is more higher than that. You all are here to create an AI which actually respond to the queries that you want to answer, the queries, the solution that you always aspire that need to be there for, and which is also answering the exact question, which is also giving exact solution for your classroom. Imagine 200 teachers. Let's say today we have joined by 89 teachers, represent 89 different classrooms with 89 different challenges, or maybe more than that. Now imagine you all have a purpose where you are going to identify what that need to be fed to an AI. When it comes to AI, I always repeat I think in our last bootcamp also, I said AI is something that what we train AI is what we are going to get it back. AI performs better when we train it better. If we feed a wrong information, then it will also start giving us wrong information. So if we talk about ChatGPT, if we talk about Gemini, all these resources, all these AI models have been trained with immense data. Now we are talking about these, and the thing about all these tools are not trained for the use of educational purposes. These tools are not trained by teachers specifically for addressing a mathematic problem in classroom. Or let's say we have a problem for grade 10 mathematics. If you go and ask ChatGPT, it will give you something, but at some point you might not find it very relevant, or at some point you might not find it aligned with our national curriculum standards or our real classroom needs. So that's where it's important we have a set of teachers who represent different classrooms, who are coming here together to explore and also to experiment how AI as a technology. We all know that AI is not a technology that can be avoided. AI will always come, and all AI will always there in the future. So education, future of education will also lie within AI. Now, if we specifically talk about calculator, when we introduce calculator, there must have been, certain people who were opposing that, okay, calculator is going to affect students' thinking capability, or maybe the way they are calculating, or the way they are going to, everybody is going to use calculator. So they might not do a lot of practical problems with hands. But we adapted to calculator. We are now using calculators, but think about how it got introduced, and think about where we are right now. The same way technology, AI technology is going to advance, but the advancing should be shaped with the support of teachers. Otherwise, we know that there are so many ways AI can actually destroy the current education system if it's not guided properly. That's why we have our educational practitioners, our leaders who are working on bringing AI-related policies, AI-related institutional frameworks, so that AI is effectively integrated. Now, you as the first large cohort for this Teacher in the Loop AI, are part of a very unique program where teachers are actively involved in shaping an AI tool. Now, what is going to be the outcome? Outcome is going to be a tool which actually listen to the teachers, a tool which is made by the teachers, which is shaped by the teachers. Your feedbacks, your whatever resources, your expertise, everything will be used to shape this tool. Now, this is the process. This is something that we have designed for next 2-3 months, where we'll be engaging with certain activities. You'll also be working with the AI tool. You'll also be learning, rather than learning about different AI tools. Think about, you're working with an AI tool and you're learning by shaping that specific AI tool. Now, this is a very practical way of learning how an AI works. Now, once you know how exactly an AI works, then you will also be able to see where you have to work on supporting the AI tool, and where you have to limit the use of AI tool. And you will also able to understand better from your student's perspective as well as from your teacher perspective, because now you know how exactly the thing work. Now, it's not that, I am introducing a new tool and you know how to use that tool. It's also that a specific set of teachers, or you are the one who is shaping the tool itself. So, and there is also a trust that we are going to create when this is a tool which is developed by the support of you or support of teachers. Then the trust towards that tool will be more compared to any other educational tool. And the program that we are designing, and the aim that we have, is to come up with a tool and come up with a solution which is more putting the teachers at the center of AI transformation. Now, this is the major goal. This is what I want each one of you to keep in mind. You are a part of a bigger picture. You are part of a bigger purpose involved in AI integration in school education, particularly in school. So this is more like a collaborative approach. Now, where there will be a lot many things that we'll be learning throughout the program. There will be many sessions which will be very insightful, where you are going to learn many new things, not just as someone who is just attending a webinar, or someone who is attending a session on AI literacy, or AI or about digital tools, but also someone who is actually contributing, someone who is actually actively involved in activities and practices which are related technically, or which are actually giving some outputs as well, or some outcomes as well. Now, I hope that is very clear. Now, as the next step, we'll also be having specific sessions, and hopefully in the month of November, hopefully in the first week, we'll be introducing our tool as well. Our tool, we are working with IIT Jodhpur, where our tool is being designed, AI tool specific to mathematics. And this tool, once the tool is ready, we'll have certain sessions introducing you to about the tools. Before that, through this program, through this competition, we are going to crowdsource resources, and you as the key pillars of this program, key pillars of this cohort, are the one who is going to review those resources and going to check the effectiveness of the resources. But that said, this competition is a must for each of this cohort of teachers. We would expect each one of you to participate in this competition. Even though it is open for all the teachers, we want to invite ideas from all the teachers, but it's mandatory for each of the cohort teacher to participate. We would request each one of you to share at least 3 best resources that you have in your hand against the topic areas. Now, we all know that each one of you were put into group and you came up with you identified certain problems. Now, the problems are available. Everyone can see that what are the problems that we have identified. Now, you might be having at least for 3 topics, you might be having some kind of resource or some kind of approach that you already have. So we request everyone to share your best practice, your best resource, and be an active participant in this competition. After that, we'll be distributing the resources among the groups. Then your mentor will guide you through how you can evaluate the resources, and each group is supposed to give at least certain number of resources where you can, if you as a teacher is saying go to for that resource, and if you think okay, this is a resource that is actually going to benefit students, then we are going to train the AI tool with those selected resources. So I hope that is very clear about what are going to happen as next. So next we have the evaluation of resources. Then we'll be processing with the training of the AI tool with the resources that has been selected. Then after that, we'll have a couple of sessions in the November, mostly online. And of next offline bootcamp, we'll inform you at least 20-30 days prior, so that, and again, next bootcamp will inform how it is going to happen. But at least we'll try to inform you 30 days before. Either we will be inviting half of the groups, then another half will be invited, or it will be according to group wise, according to the comfort of all the teachers, because we want the maximum participation for our next bootcamp as well. Because in next bootcamp, we'll be actively involved in working with the AI tool. We might need laptops, we might need computers. So we'll also see the technical feasibility as well. Because we know that if technicality is involved, bringing all 200 teachers together might cause a lot of network issues or maybe technical issues. So we'll try to design that program in a way that it is comfortable, it's smooth, and it is easily practical. Now, moving ahead, we'll start with the session. We are truly privileged to have Dr. Ramesh Chandra Srivastava leading this series. So today is the first session. Many of you have already interacted with him during the bootcamp, and you already know the depth of insight and clarity that he brings to mathematical concept. Dr. Ramesh Chandra Srivastava is someone who is having rich experience in mathematics. He also works in different projects. Individually, he's involved with CBSE works as well as NCERT works. And many of you are already might have already know him. So this session will give us an opportunity to learn, reflect, and discuss together. Each masterclass will be about 45 minutes and followed by a short Q&A session where you can share your questions and classroom experience. With that, let's begin our first session of the TiL-AI Masterclass series. Please join me in warmly welcoming Dr. Ramesh Chandra Srivastava, our subject expert and mentor, to lead today's session. I would also request everyone that there will be a Google form shared for your attendance. So I would request everyone to fill that Google form in the end. I'll be sharing it in the chat box.
Thank you,
Yes,
Khalid.
over to you.
Thank you, Khalid. Good everyone. Good evening, everyone. So welcome in the series of the master classes. Today I will take the 2 units of the real numbers as well as the polynomials. Though the time is a very short, but you all have identified the challenging topics of the both the units and the real numbers. The challenging topics are the distinguish between the Euclid's lemma and algorithm. finding SCF and LCM of the three numbers, solving real-life problems using SCF and LCM, proofs of irrational number, and the prime factorization of large numbers, application of division lemma, and the last one is the understanding why a number raised to power n ends with 0. Similarly, first of all, I will take the challenging topics of the real numbers. So I'm going to share, first of all, before going to the challenging topics, I will brief the some very insight of the some concept of the real numbers. Then we will get one by one the challenging topics of the real numbers as well as the polynomial. So please wait. I'm going to share my PPT. I'm audible or not? I'm audible or not?
Yes,
Yes,
sir.
sir,
Yes,
you are
sir, you're
Yes,
audible.
yes.
sir.
First of all, I request to all of you that please keep a paper and pen or pencil, because it's a master class. There is a need of some activity as well as some uh, questions. So please keep the plain paper as well as the pencil or pen. So, in the real number unit, in this unit, we will discuss very important properties of positive integers, namely the Euclid's division lemma and the fundamental theorem of arithmetic. These two articles of these real numbers are very, very important. And as I know that most of the teachers and they left these two important properties of the integers, Euclid's division lemma as well as the fundamental theorem of arithmetic. Both are applicable in our daily life, and I will discuss about these two like that. Now come, what is the Euclid's division lemma? This is the general definition. But there is a very some insight of this lemma that's for any two positive integers. Please go through the some very specific point, that is the positive integers a and b, and where it is given that a greater than or equal to b, there exists unique integers. This is a very important word, that the unique. What does mean by the unique integers? Q, that is the quotient, and R the remainder, such that A is equal to BQ plus R, where 0 is less than or equal to R is less than B. This is the general definition of the Euclid's division lemma. So there are two things that is I would like to discuss about this lemma. That is Euclid's division lemma underprints the Euclid algorithm, which is efficiently used to find the greatest common divisor or SCF of the two numbers. First of all, what is the difference between the lemma and algorithm? Algorithm is a step-by-step procedure. That's a systematic procedure to find the results of the with the application of the Euclid's division lemma. So here, I will provide you a question that when the Euclid's division lemma is defined only for only positive integers, but in daily practice, in classroom practice, how you get that -4 is divided by -2 is equal to 2. -4 and -2, both are the negative integers. So here, the Euclid's division lemma is not applicable because -4 and -2 both are the negative integers. So how we can get this result? This is equal to 2. It is a challenge. And you know, it's a very conceptual. Please go through that. What is the division? That is the recurring subtraction. So when you divide -4 by -2, and this divisibility is defined only for the positive integers, then what will be the procedure to get the result of -4 divided by -2 is equal to 2? Most of the students in the classroom, they say that the -4 divided by -2, minus cancelled out, and 2 to the 4, and in this way they understand that the value is a 2. So it's not a fact. Here in higher mathematics, the division algorithm is extended to all integers, not only for the positive integers, not just for positive ones. Here, the extended statement is the Euclid's division lemma is for any two integers a and b, with b is not equal to 0, there exists unique integers q and r such that a is equal to bq plus r, but the condition here differs. In extended Euclid's division lemma, that is r is less than mod of b. It is very important in extended statement of the Euclid's division lemma. So now come apply this extended Euclid's division lemma. Let a is equal to -4 and b is equal to -2, and the modulus of b is equal to 2. So we can write it as a -4 is equal to mod of -2 into 2 plus 0. Here at the place of q is 2 and r is 0. And here 0 is less than of minus mod of b, that is that a mod of b, 0 is always less than mod of b, that is 0 is less than 2. So it satisfies the generalized form of the Euclid's division lemma. So in our textbook, the 10th grade mathematics in NCERT, only the Euclid's division lemma is defined. And so many problems of the division regarding the divisibility of the integers, like you can say that it may be the positive, it may be the negative. So extended Euclid's division lemma is very important. So one thing is very important. If you divide -4 by 2, so use your pen and paper, then you divide -4 by 2. Are 4 divided by -2? Are -4 divided by -2? So how can you divide this through that the procedure of the recurring subtraction? If you divide 4 by -2, then what does it mean? That is through the recurring subtraction, 4 minus -2, that is 6. Then again 6 minus -2, that is 8. So you always subtract, but get some higher number. So it doesn't follow the mathematical operation rule of the division. So what can I do it? So we can use the only procedure of the extended Euclid's division lemma. How? Now come on this number. That is, if you want to divide 4 by -2, and the result is -2. Here, come on the number line. What does mean by the 4 divided by -2? First of all, here in the figure, something is wrong during the making a PPT, but in the next slide, go in this second example, -4 is divided by 2, and how we can get the -2. So what does mean by the -4 divided by 2? It means that how can you get to jump to up to -4? So you can see on the number line that what is 2, that is 0 to 2, and you have to jump on the -4 from the 0. That is, first of all, the first jump you will reach on the 0 to -2. First jump. And then -2 the -4, that is second jump. The length are equal, 0 to 2, 0 to -2, and -2 to -4. These intervals are equal, and -4 divided by 2 means, that is, how can you jump on -4 by 2 from the 0? So in this way, because you jump in the left side, that is why the result is -2. Now, similarly, if you divide -4 divided by -2, what does it mean? That is, you have to go on -4 through the -2. So that is, what is -2? 0 to -2. And you have to approach in the same direction at -4. Then the same direction, you jump 2 times. That is 0 to -2 and -2 to -4. And that is why the result is 2. So through this activity, you can define, through this activity, the division of the negative integers, as well as you can divide the positive integers. So this real line activity, we can get the required results. With the help of Euclid's division lemma, we compute the SCF of the two positive integers. We can compute the SCF of the two positive integers as well as for the two negative integers also. The SCF of two negative integers also exists, but the SCF is always positive. And the second theorem is the fundamental theorem of arithmetic. This theorem associates with the multiplication operation, and the Euclid's division lemma that is associated with the division operation. So now come on the fundamental theorem of arithmetic. This is a very important and it is very applicable in our real life. I will see some application of these two theorems in our real life. Every composite number can be expressed as a product of primes in a unique is a very important word. What does mean by the unique? The primes in a unique way apart from the order in which the prime factors occur. First of all, what is the prime number? You know it very well. And what is the difference between the composite? Please mute your mic. What is the difference between the prime and composite? So you know it very well. So here, suppose we have the sum product, that is the prime product 2 into 3 into 5 into 7. Unique means, that is, again, it is equal to as 3 into 5 into 7 into 2. The order may be changed, but the set of numbers, the set of prime numbers will be same. That is the uniqueness. That is, you can place the prime numbers at like that 2 into 3 into 5, 7, 3 into 5 into 7 into 2, 7 into 5 into 3 into 2, like that. But the prime numbers will be the same. That is the uniqueness. Or any other possible order in which these primes are written. It has many applications both with the mathematics and in other fields. First of all, any number more than 1, any composite number can be factorized into the prime factors. So please mute your, please, I am audible or not? If I am audible, please mute your the mic.
You are audible. Please continue. I have muted
Yes.
the person.
So here we have the only the relation between the SCF and LCM of the two numbers only. That is the SCF of AB and LCM of the AB is equal to the product of the numbers A into B. It is a very obvious property and the relation between the SCF and LCM. But here in our challenging topics, here is how we can get the SCF and LCM of the three numbers. So a relation between the LCM and SCF of the three numbers is not in the same manner as for the two numbers, that is LCM of three numbers into SCF of three numbers is equal to the product of the number. But here it is different for the three numbers. Why it is so? I will discuss it. That the LCM of the three numbers, like that PQR is equal to P into Q into R, SCF of PQR, and divided by the pairwise the SCF of the PQ, SCF of the QR, and SCF of the PR. The proof is a long, but I would like to share the procedure that first of all, any number can be expressed as the product of the prime numbers or the power of the prime numbers. Like that, if we have the 3, 4, 5 factors, then we can write it in the power of the prime factors or simply the prime product of the prime numbers. So when we get the LCM of the three number, that is what is the highest power of the common common prime numbers as well as the rest of the prime numbers, and SCF the lowest power of the prime numbers. So in this way, we can get the LCM and SCF of the three number, but with the help of this relation, LCM of the three number, so we can establish our relation between the SCF of the three numbers and LCM of the three numbers with this formula. The proof is long, so we have the very limited times. So you can prove it very easily through the factorization of the numbers, prime factorization of the numbers. And what is the applications of the fundamental theorem of arithmetic? So application is a very important. So in finding the SCF and LCM, it is a very common and it is written in your textbook. So I don't like to explore on this application in finding the SCF and LCM. But like that, the two traffic light blinking every 12 seconds and 18 seconds will blink together every 36 seconds. These are the such a very simple application of the fundamental theorem of arithmetic in finding the SCF and LCM. But here it's very important in computer sciences, especially in the cryptography, internet security, because every number can be written in the product of the prime numbers. So when we use the passwords in online banking, they are protected using secret codes made from the large prime numbers. We generate a large prime number, 10, 20, 50,000 digits prime numbers. And it is a very easy to multiply primes, but very hard to find the original primes from the product. If we have some 20 or 25 digits prime numbers, then it is very difficult to find, to detect the individual prime numbers by multiplying, which we get the 21 like the prime numbers. So security point of view, this application of the fundamental theorem of arithmetic, then how can we get, we can factorize any number with the help of the product of the prime numbers. So the application of the prime number in a computer science, especially in the cryptography, is very important. Now, in repeating patterns and time problems, like that, some events are repeating and related to the time problems, these are the given in your textbook. So I don't like to discuss on this such type of the application. These are given in your textbook. Now, irrational number, it's very important that here two things are very important: irrational number and transcendental number. The transcendental number is not given in your textbook, but that is very important. Like, so I will discuss. I will please mute your mic. So root p is a irrational, where p is a prime. If p is a prime, then root p is always an irrational number. The theorem is a very important. It is given in your textbook, but it's important and it is very applicable to prove the irrational number. That is the challenging topic of your this competition, OER competition. If p be a prime number and p divides a square, then p divides a. This theorem is given in your textbook where a is some positive integer. So I don't like to give on the details of this proof. It is given in your textbook, but the result is that if A is written in the product of the prime numbers like that P1, P2, Pn, then A square is also equal to P1 square, P2 square, Pn square. And if P divides A square, then through this theorem, the P also divides A. So this is a very important and it is applicable to prove the irrational number like root of 2, root of 3, root of 5. These are the irrational numbers. Now come on, this is a very important, though it is not a range of the your 10th standard, but it is totally related with the real numbers as well as the irrational number. What is the transcendental numbers? The transcendental number is a real number or complex number. Don't go on the complex number, only go through that it is a real number and it is a not root of any algebraic equation with the integer coefficient. Transcendental numbers are those irrational numbers. Those are not a solution of any algebraic equation having the integer coefficient. This is the property of the transcendental number. Like that pi. Pi is a transcendental number. Pi cannot a solution of any equation which have the integer coefficient. That is, if you have the some x square plus 2x plus 1 is equal to 0, then pi cannot satisfy it. That is, pi square plus 2 pi plus 1 cannot be 0. So any type of equation, the pi cannot be a solution of such type of the equation with the integer coefficient. So this is the transcendental number pi a. These are the very your common transcendental number. And having the value pi, that is 341415, 3.1415 like that. And pi is irrational. Every transcendental number is irrational. But every irrational number is not a transcendental. Because irrational may be the solution of any equation. But transcendental number cannot be the solution of any equation. Why? Because so many causes are there. So now come on. This is Euler's number. The value of this is 2.7182 like that. Every transcendental number is irrational as I have stated. The number E was first discovered while studying compound interest. That is E is equal to limit n tends to infinity 1 plus 1 by n, not x. It is a misprint. 1 by n raised to the power n. So it is the not the level of the 10th standard. So only go on the what is the Euler's number, and it is a transcendental number. It cannot be the solution of any equation. Now, what is the another thing is the golden ratio. It is a very important. It is very applicable, and that is the value phi is equal to the golden ratio is the symbol is phi 1.6180, that is 1.618, and phi is equal to 1 plus root 5 by 2. And what is this? A, B, what is this? If any line segment or anything is divided into two parts, A is a larger part and B is a smaller part, then if though both parts are satisfied with this relation, A plus B divided by B is equal to A by B. A plus B divided by B is equal to A by, then we can get the golden ratio. So what is the application of the golden ratio in designing? You can see the design of the United Nations Secretariat based on the golden ratio and how it is applicable in the designing, architecture, and golden rectangle, golden triangle. These are the very important when we discuss about that the rectangle and triangle. Then we will discuss about the how can we get the golden ratio, how we can get the golden rectangle as well as the golden triangle. Fibonacci sequences. What is this is the very important. The when we start 0, 1 and add the two numbers, then and after adding the two numbers, we will get the next number. That is 0, 1, 1, 1, 2, 3, 5. 1 plus 1 is equal to 2, 2 plus 3 is equal to 5, 5 plus 8 is equal to 13. So this sequence is a Fibonacci sequences. And what is the application of this? When we go as well as 35, then next number, and when we divide the two consecutive numbers like that, 35 divided by 21, 21. So we will reach about that the golden ratio, that is 1.618. This is the property of the Fibonacci sequence, and this is the application. The application is in our real life. That is the I will discuss when we discuss about the triangle and the rectangle orthogeometry. What is the role of this Fibonacci sequence? Now, some things are about the polynomials I will discuss. Please wait. I am going to share the second PPT. Now, in this unit, the polynomial, the second unit of the strengthened mathematics, some challenging topics which you have already identified. If alpha and beta are the zeros of the polynomial, then find the alpha square plus beta square, as well as the alpha cube plus beta cube. The second challenging topics is the interpreting sign of the coefficient from the graph of the polynomial. If the graph is given, then how can you find the sign of the coefficient through that graph directly? It's a very good topic. And third one is the difference between the zeros of the polynomial px is equal to y and py is equal to x. The next one is the effect of signs and values of a, b, and c. What is a, b, c? In the quadratic polynomial, these are the coefficient of the variable. On the graph of the polynomials, application of zeros in real life contexts, relation between the zeros and coefficient of the polynomial, and the last one is the finding values of a and b when zeros are given. These are the challenging topics of the second unit. So first of all, we will discuss some elementary things or some conceptual things about the polynomial. Then we will discuss here some challenging topics which are not in the textbook. First of all, it is a very easy. The px is a polynomial in x. A real number k is said to be the zero of the polynomial if pk is equal to 0. This is a very normal thing. This is the general polynomial where n is not equal to 0. And when we say polynomial is a function, polynomial as a function, it is a very important. Because in the function, we have to need some two non-empty sets, one domain and the second will be the codomain. We mean that for every real values of x, the polynomial gives one unique value of x. That is, the polynomial behaves like a function. Graph of a polynomial, it is a smooth and continuous curve. It has no breaks or sharp corners. This is the very important, that is smooth and continuous curve. And what is the zeros of the polynomial? The points where the graph cuts the x-axis are the zeros or the roots of the polynomial. It is given in your textbook. But through the graph of the polynomial, we have so many information. Not only about the zeros. We will discuss these things. What such type of the information we can collect from the graph of the polynomials. Now, suppose the graph is given in your textbook. If the degree is given, and leading coefficient is positive. Leading coefficient means highest degree of the variable. The coefficient of the highest degree of the variable is positive. Both ends of the graph go up. If suppose x square plus 2x plus 1, it is a polynomial, and the coefficient x square, this is the leading coefficient is the 1, that is a positive. So here through the graph and right and left and the graph go up. it दोनों ऊपर जा रहे हैं. So if we have the even degree of the variable, the highest degree is even, and the coefficient is positive, leading coefficient, that is the coefficient of like that x square is 1. So that is the end of the graph go up. Now come on this. If the degree is even and the leading coefficient is negative, like that, minus x square minus 2x plus 1, like that, both ends of the graph go down. So these are the very important things. With the help of the coefficient and the degree of the polynomial, either even or odd, we can judge the end points, the end of character of the ends of the graph, either it goes up or go down. Now in this graph, if the degree is odd and leading coefficient is positive, the graph goes down on left, goes down on the left in the third quadrant, and go on the right in the first quadrant. If the degree is odd and leading coefficient is negative, that is if we have the suppose minus x cubed, the leading coefficient is negative, that is minus 1, and the graph goes down on up in the second quadrant and down on the right in the fourth quadrant. And it is very obvious that the graph of this is the linear polynomial. Now this is the quadratic polynomial. And now the quadratic has a maximum value. The vertex is at the highest point. This is the another very good information. Through graph, we can find the highest maximum value of this polynomial at the position of the vertex at the highest point. Similarly, if the quadratic has a minimum value, the vertex is at the lowest point. So through the graph in your challenging topics, these are the topics are given. That is with the help of the graph, how we can find the different information about the coefficient of the polynomial, about the maximum or minimum value of the polynomial. So these are the tips how we can get the minimum or maximum value of the polynomial. Then what is the zeros? Zeros is a very common. It is given in your textbook. The points where the parabola cuts the axis, the quadratic polynomial, and the points on the x-axis are the zeros. But in the case of only here, the two cases are given. Again, we will discuss on that. Px is equal to y and py is equal to x. If the graph cuts on the x-axis, then we can get the zeros of the like that px is equal to y. And when the graph cuts on the y-axis, then the value on the y-axis, that is py is equal to x. So this is the main difference. This is the challenging topics in the polynomial chapter. That is how we can differentiate between the zeros of the px is equal to y and py is equal to x. So we can draw the graph of the polynomial as the independent variable x and dependent variable y. And in second case, we can take the independent variable y and dependent variable x. So when we plot the graph, we can find the zeros according to the graph, either in the form of the x or in the form of the y. These two topics are challenging in the identified challenging topics. Now, two distinct Roots. Parabola cuts axes are two distinct points. In the some textbook, the zeros as well as the roots are given. Mostly we use the roots in the case of the equation. That is the solution of the equation. But in the case of the polynomial, we use the zeros. The parabola cuts x-axis at two distinct points and one real root. How we can get the one real root? When the parabola just touches the x-axis, that is the axis is the tangent, and parabola does not touch the x-axis, no real roots. And what is the application of this zeros of the polynomial as well as the application of the polynomial in our day-to-day life? That is then the projectile motion, throwing or jumping objects. The height of a thrown ball can be represented by a quadratic polynomial like that. I have taken some example. Suppose hx is equal to minus 5x square plus 30x plus 15. Here the coefficient of x square is negative. So we can roughly sketch the graph of this parabola where the coefficient is minus 5. And now in the second, in the vehicle motion, the zero tells the distance or time when the vehicle comes to rest. If we find the zeros of the vehicle motion, then we can judge how the vehicle comes to rest and what will be the time when the vehicle comes to rest. So these are the application of the zeros in our daily life. Architecture and bridges design. The shapes of the arches, cables, and bridges often follow parabolic curves. The zeros show the points where the tractions meet the ground or supports, helping in constructions, design, and stability checks. Like in our Prayagraj, the bridge on the Jamuna bridge, and that is the hanging bridge, and the shape is the parabolic, and the road touches the road acts as a tangent at the vertex, and so at the vertex the zeros is zero, where the ground support helping in construction, design, and stability checks. We can use the zeros of that particular the polynomial either in the parabolic form or in other form also. Water in the path of the water from a fountain nozzle be modeled as a parabola. Is the modeled in fountain, especially in the hill station, you can see, or in some picnic spot, we can find the zeros where the fountain, the water drops on the ground, touch the ground. With the help of the zeros, we can find the distance where the zero indicate where the water leaps and hits the ground, useful for angle and pressure adjustment. So these are the some applications of the zeros as well as the application of the polynomials. And what is the zeros and the coefficients of a polynomial? The sign of a coefficient A, B, and C. These are your challenging topics. The role of the sign of the coefficient A, B, and C in the quadratic polynomial, that is Px is equal to Ax square plus Bx plus C. So if A is positive or negative, or B is positive or negative, or C is positive or negative. So in a quadratic polynomial, it is very easy to find the nature of the A, B, and C. But in the higher degree of the polynomial, like in the cubic or more than cubic, it is very difficult. Only you can find the highest power of that coefficient as well as the constant. But in our 10th class mathematics textbook, we can judge the character of this coefficient up to the quadratic or cubic polynomial. So this is the very important. Coefficient, A shape, and direction of opening. So first of all, it decides whether the parabola opens upward or downwards and how wide or narrow it is. So this is your this topic is in your challenging topics. If a is greater than 0, like that ax square plus bx plus c, if a is positive, then shape will be upward. If a is negative, the shape will be down. The coefficient of b and c, these are the very important. The b is coefficient of x and c is a constant. If b is a greater than 0, the vertex lies on the left side of the y-axis for a is equal to 0. And in the same case, for a is equal to 0, if b is less than 0, that is negative, the vertex lies on the right side of the y-axis. And if b is equal to 0, that is no term of the x, the parabola is symmetric about the y-axis, centered at the origin if c is equal to 0. The third case, if c is equal to 0, then the parabola will be centered at origin. Coefficient now come on the character of the coefficient c, the vertical position, the y-intercept. When we see the y-intercept of the curve, then we can judge the character of the c, the character of the constant, that is the c, ax square plus bx plus c. C is a real number, but it is treated as a constant. So c is the y-intercept, that is the point where the parabola cuts the y-axis at x is equal to 0, y is equal to c. If c is greater than 0, that is positive, the parabola crosses y-axis above the x-axis. If c is negative, parabola crosses y-axis below x-axis. If c is equal to 0, parabola passes through the origin. So c affects the vertical position. Through c, we can judge the vertical position of the graph. Now take this in this example, if y is equal to 2x square minus 4x plus 1. Here a is a 2, b is a minus 4, and c is a 1. B is equal to minus 4, that is less than 0. The vertex is to the right of y-axis. And here c is equal to 1, that is greater than 0, crosses y-axis above the x-axis. If zeros of the quadratic polynomial ax square plus bx plus c are alpha and beta, the first challenging topic is in your, we can judge if alpha and beta are the zeros of any quadratic polynomial. So through ax square plus bx plus c, the sum of these zeros is equal to minus b by a, and the product of the zeros is c by a. But when we want to get the alpha square plus beta square, or alpha square into beta square, then how can we get? We can use the identity. That is, with the help of alpha plus beta and alpha beta, we can find the value of the sum of the alpha square plus beta square. That is alpha plus beta whole square minus 2 alpha beta. Similarly, we can get the alpha cube plus beta cube with the application of the algebraical identities. So this is the first challenging topic. So if we know the zeros of any quadratic polynomial, with the help of this zeros of the quadratic polynomial, we can get the power of these zeros, sum of the power of the zeros, product of the power of the zeros, like that. So we can make the polynomial with the zeros alpha and beta. If we have the alpha and beta are the zeros of any polynomial, we can make a polynomial with the help of these zeros. That is, if alpha and beta are the zeros of a polynomial, that px is equal to a into x minus alpha into x minus. Why we multiply by a? Because when we compare this to ax square plus bx plus c, then we get the ax square minus a times alpha plus beta into x plus a alpha beta. And the first term are the same, we can compare easily with the help of this. Px is equal to a into x minus alpha x minus beta with ax square plus bx plus c. So these are the some things which I discussed. But one thing in your challenging topics is very, very interesting and very, very. So please do this activity on your paper. The challenging topics are number ends in the digit 0 if and only if it is multiplied a multiple of 10. That is, if a number ends in the digit 0. The topic is this, please bet. I can share the challenging topics here. That is finding in the case of the real number, understanding why a number raised to power n ends with 0. This is the very good topic. That is in the real number, that understanding why a number raised to power n ends with 0. Suppose we have some number like that a, and a raised to the power n. Then how it is ends at the digit 0. So if the number ends in the digit 0, if and only if it is a multiple of 10. It is a very obvious. Since the prime factorization of 10 is, what is the 2 into 5? That is 2 is also prime and 5 is also prime. So the product of this 10 is equal to 2 into 5. For any number to be a multiple of 10, it may have both 2 and 5 as a prime numbers. So please do on this paper, on your notebook. So 10 is equal to 2 into 5. So if a number a rose to the power n, where n is a natural number, ends in 0, it means that the prime factorization of a raised to the power n must contain at least one factor of 2 and at least one factor of 5. That is, a raised to the power n is equal to a into n into a n times. The prime factor of a raised to the power n are the same as the prime factor of a. Screen is not visible because this is the activity you can do on your notebook. This, you can do it, write it on your notebook and do it as some assignment during this session. That is, a raised to the power n is equal to a into a into a into n times. And the prime factor of a raised to the power n are the same as the prime factor of a. It is a very obvious. Like, take example 6. What is the prime factor is 2 into 3. If you take the 12, 2 raised to the power 3 into 3, that is 24. And at the, if a is a 15, you can write it 3 into 5. But in the case of 20, you can write it 2 to the power 2 into 5. Here, 2 and 5 both are the prime. And in the case of 50, 2 into 5 to the power 2. In the case of 100, like that, the number at the end 0, you can factorize it in the prime numbers. And the theorem is a very obvious. The challenging topic is very obvious. That is a number raised to power n ends with the 0. So this is the application of the prime factorization of the numbers. That is, at any number, if we find the 0 at the end, then there must be some prime factorization of 2 and 5 both, not only 2 or 5, but the both. When the 2 and 5, at least 1 2 or at least 1 5 must be the factor of that number ends at 0. So this is the very important challenging topics in the real number. Similarly, in our polynomials, relation between the zeros and coefficient of the polynomials, it has been discussed. Find the values of a and b when zeros are given. That is the sum of the zeros are minus b by a, and the product is c by a. And the first challenging topics, that is alpha or beta. Here, p and q are written it is a typing mistake. So with the help of alpha plus beta and alpha beta, we can find with the application of the identities alpha square plus beta square, alpha cube or beta cube. So like that. Now come on this difference between the zeros of the polynomial px is equal to and py is equal to x. I have discussed this. So almost all the challenging topics today in this session we will discuss.
Is not visible.
Now I will give you some time for the question, you can ask the question related to the two topics, real numbers as well as the polynomials. And here, the only object is in the future, when you will generate the open education resources through AI tool, or if you are going to train the AI tool also, then the subject must be clear, or the insight of the topic must be clear. In your textbook, NCERT textbook, so many things are not given. Like that, the application part is not there. So always go through the application part. When you will generate the teaching material or some activity or lesson plan or assessment, then there must be some knowledge about that, the application part, analyzing part. So analyzing and application part are very important. Analyzing part is a very important for the conceptual point of view, and the application part is also a creative. So with the analyzing part, you can develop the analysis of that content and how we can use these content in our day-to-day life or in our real life or in somewhere where you need it. So now, please one by one share your you can ask the questions. First talking the real number.
Your video is off. Sir, your video is fine.
Good evening, everyone. The forum is open for question and answer. If anyone is having any questions, you can raise them. You can unmute and you can speak the question, or you can write them in the chat box.
So you can ask any question, first of all, about the real numbers and then the polynomials. Because in the very short period, the challenging topics which you have identified in the last boot camp, in the last week of the September in Delhi. So other than the challenging topics, you can ask the question.
So there is a question in the question answer forum.
Yes. Yes. We can define the SCF and LCM for the negative integer, because here the fundamental theorem of the arithmetic is useful to find the SCF and LCM. That is why the SCF and LCM are always positive for the negative numbers, because the factors are always the positive. Like that, if we want to find the SCF or LCM or -6, -38, like that, or whatsoever the numbers, more than 2 numbers, then the factors is always we can take the positive, and the SCF and LCM is always positive. So with the help of this fundamental theorem of arithmetic, we can factorize the negative numbers also in the prime factor, and then we can get the lowest power of that prime factors as SCF, and the highest power of the prime factors as well as the rest of the factors as the LCM.
Can we find the HCF or LCM of fraction also? Like 1
Yes,
by
yes,
2, 1
why
by
not? Why not? Yes, yes, this is the from the upper primary classes up to the earth standard. We get the SCF and LCM of the factorization of fractions. So these are the very elementary questions. If you want to go the relation between the SCF and NCF of the 3 numbers, that is very important. And here in the textbook, it is the proof is not given. So if you do this some on the it's a long process, but with the pairing of the numbers of the 2 numbers, SCF or LCM, then we can establish the relation between the SCF and LCM of the 3 numbers. That is, the LCM of the 3 numbers is equal to the product of the numbers, and the SCF of the 3 numbers divided by that the formula which is given. That is the SCF of the 2 numbers into the SCF of the next 2 numbers into SCF of the next 2 pairwise the division is there. Next question is, what are the factors of any negative number, say 30, minus 30. So you can factorize it. The negative sign only shows that is minus 5 into 6 or minus 6 into 5 or 2 into 5 into 3. So always the factorize in the it into the prime factor. The sign is not very important. Like that 30, that is the 2 into 3 into 5. 2 into 3 into 5, these are the prime factors. Negative sign is another. And if you want to find the SCF, 2 into 3 into 5, what is the SCF? 30 minus 30 and take up some another number, then we can get, if we take the minus 30, minus 50. Suppose, 50 and minus 30 and 50, and want to get the SCF or LCM of these two numbers, then only factorize into a prime numbers and then take a lowest power of that factor as the SCF and the highest power of the prime numbers as the LCM. We can do the same process as for the positive integers, but it is the LCF and LCM always will be positive. Next question.
Sir, we have some questions in the chat box.
Yes, explain the difference of y is equal to px and x is equal to y in context of the polynomial. It's a very good question. So y is equal to px. Here, polynomial treated as a function. Here in the px is equal to y. X is an independent variable, that is x belongs to the set of domain and y is the element of the set of codomain. So when px is equal to y, we take, then the graph cuts the x-axis. The points on the axis tells about the zeros. But in the case of x is equal to py, the graph intercept on that is the y is an independent variable and x is a dependent variable. So on the y-axis, the graph cuts on which points, the points tells about the zeros of the x is equal to py. These are the differences according to the graph of the function y is equal to px and x is equal to pi. Because here, most of the, in our textbook only, the px is equal to y graph is given and no graph is given about the x is equal to py. So we can plot the x is equal to py also. Like that, a parabola y square is equal to 4ax. X square is equal to 4ay. So these two types of the parabola, that is the quadratic polynomial graph of the quadratic polynomial, when y square is equal to 4x and x square is equal to 4y. So these graphs cuts the axis into the different points. When it cuts the x-axis, then the zeros will be on the x-axis, the points on the x-axis. When it cuts the y-axis, then we can get the zeros on the y-axis. So this is the difference.
Sir, I think we have exceeded the time for today. Maybe some other questions we can take it later.
How
in
can
the
we
coming session.
in the yes. Kindly provide insight for lemma. What is the lemma? Lemma is it is a supportive statement of to prove the theorem. Theorem is a big statement, and we can get the help of this lemma. We can prove the theorem, and theorem lemma. No need of any proof of the lemma, but it is only defined. But it is useful to prove the theorem. And how can we explain to a student that negative times a negative number is positive? So we can do it through real line activity. Please draw a real line, take a midpoint 0, and the right the sign convention is positive, that is negative. Suppose if you want to multiply -2 by -3, that is, it means that -2 is added -3 times. So no meaning of -3 times. That is -2 is added 3 times opposite to of -2. -2 into -3 means that is -2 is recurring added -3 times. That shows that -2 is added 3 times opposite of -2. Opposite of -2 means that is 2 plus 2 plus 2. That is why we get 6. So in this way, through this activity, we can show that negative multiplied by negative, we can get the positive. So can even numbers be negative also, or odd numbers can be negative also? Can even number be negative? So here it's a very conventional that when any number is divided by 2, it is even. When it is not divided by, it is an odd number. So the even and odd number is maybe positive or maybe negative. So the 0 is neither even nor no, 0 is a even because we alternate 0, 1, 2, 3, 4. So because we get the 2 is a even, then 0 is also even. Similarly, we can, when we go from the left of the 0, that is -1, -2, -3, -4, these are the negative numbers. But if it is divisible by 2, then it is even, or it is not divisible by 2, it is an odd. So this is a sign convention only. The negative number is only according to the sign convention, lies in the left of the 0 and the positive right of the 0. So 2, 4, 6, 8 also even, and similarly -2, -4, -6 also even, because both are divisible by 2.
Sir, we have one last question in the chat box.
In natural number, there is a no zero elements. In natural number, there is a no zero element from where we got 0 in 10, 20, etc. In natural number, there is a no zero element. Yes, there is the no zero element. From where we got 0 in 10, 20. Oh, so 10, 20, these are the natural number. So because in the natural number concept, when we are going to count the number 1, 2, 3, 4, 5, 6, 7, 8, 9. Because before the invention of 0, only we have the knowledge of the from 1 onwards. So that is the natural number. So 10, 11, 12, that 0 is not that is the not made by 10 with the help of 0. In a natural number system, when we invented the 0, then with the help of 0 to 9, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can make any number with the help of 0 and 9. So that is the point. Good evening, sir. If the parabola is not interesting or touching the x-axis, but lie in the first quadrant, then how to explain about number of zeros? And there will be no zero. If the parabola not touches or intersecting the x-axis, if the graph is px is equal to y, that is the parabola. In the parabolic function, x is independent and y is dependent. Then in that case, there will be the no zeros. So thank you. I will hand over to the, what is the LCM of 2 and √3? Yes, good. Because here, it's a good question. The last question is, yes, not possible. So it is written, Anjali Sharma. Because what is the LCM? That's LCM and HCF totally depend on the fundamental theorem of the arithmetic. And what the fundamental theorem of arithmetic says, that if any number is factorized into the prime numbers, then that can be, you can get the HCF and LCM. It may be positive or it may be negative. But here √3 is some irrational number that is not an integer. That is why we cannot get.
Thank you, sir. Uh, I extend a very heartful thank to Dr. Ramesh, Dr. Srivastava, Mr. Khalid, and the entire team to provide such an opportunity of getting the deep insight to topics, which I think we have never got in past. So these sessions are very useful, and they are taking us deep into our own subject and clarity. I'm sorry to intervene, but Mr. Khalid is on travel and he made me the host for this meeting. So I'm taking this opportunity of closing this session today. Thank you, sir. Thank you for your effort.
Welcome, Agrawal sir. So I think that in the next session, we will take the pair of linear equations in the two variables as well as the quadratic equation. Then we will discuss about some more about the polynomials in the quadratic equation in details, because we have the very limited time. So I think that it needs at least the 2 hours per 1 hours for the each unit. So in the very short period, I discussed some things, challenging topics. Thank
Yes,
you.
sir. The concepts that you shared today were very useful and they were deep into the our
Thank
own
you, sir.
subject.
Thank you.
So any more questions if you have, just keep them ready. We may take them in the next coming sessions. Thank you, everyone. Have a very wonderful evening. Bye bye, everyone. We
Thank
are
you. Thank you.
ending the meeting.